And our next question is about a cubic function, right? Very exciting indeed. So let's jump right into it. It's a question that comes from Mabutla Valentine Matejo. Thank you for sending it through. Let's see what this is all about, right? So the question reads as follows. There's actually, it says, sketched below is the graph of f of x equals negative 2x cubed minus 3x squared plus 12x plus 20, which is equivalent to negative 2x minus 5 into x plus 2 squared. A and T are the turning points of the graph of f, and A and B are the x-intercepts of this graph. There's a point P with coordinates negative 3 and 11, which is a point on the graph, right? There's a random point with coordinates negative 3 and 11. We'll look at that point later because there's a question that is specifically talking about that particular point. Okay, cool. So the first question here says we need to determine the length of AB. That's what we need to worry about, number one, right? So number one, we need to find the length of AB. So we are looking for the length of AB. Now you should agree with me that for us to be able to find how long A is from B, it's just a matter of knowing what are the x coordinates of both A and B. What is x here at A and what is x here at B? So this question that is asking about the coordinates of the length of AB is basically just asking you to find the x-intercept of your cubic graph. And you guys should know for x-intercept, if you're looking for the x-intercept, we're simply going to say that we're going to let y to be equal to 0. Now, we're not even letting y to be 0 because everywhere on the x-axis, all y values are going to be 0. Now, the examiner who is asking this question is a very nice person. How do I know that? Well, because they gave you the equation of the cubic in two forms. They gave you the unfactorized format and the factorized format. So normally, you would only get the one that is on the left-hand side, the one with the cube on it, because then we want to test your abilities to factorize cubic equations. But if they are nice like now, they're just giving you the unfactorized form and the factorized form. It means they just want you to get to the answers much quicker. This is an examiner who was in a very good mood. So we will take this version, we'll take this part here and equate that to 0 and then solve for x. So you'll agree with me when we put 0 and we equate that 0 to negative 2x, right? Minus 5 into x plus 2 with a square. Our x values will just simply be x equals 5 over 2 or x equals negative 2, right? See, this is what we're going to end up with. Now, if you look here, you'll agree with me that the x value of 5 over 2 is going to be the one that is by B, and the one that is negative 2 is the one that is going to be by A, which means if you had to write the coordinate of both A and B, you'll just simply put zeros, which means the coordinate of B will just be 5 halves is to 0, and then BA will just simply be negative 2 is to 0. Therefore, the length of AB will just simply be 2.5 as well as 2. When you are dealing with distance, guys, negative signs do not matter because distance is always a positive quantity. So we're just asking you how far is A from B. We know for a fact that B is basically 2.5 away from the origin. It's at 2.5. And we know that A is actually at negative 2. So that's 2 units from the origin. So basically this means in total, the distance between A and B will just be 4.5. So AB will be equal to 4.5, right? The follow-up question, which is the second question, is also asking for something interesting. It says find the x coordinates of t. Find the x coordinates of t. Right. Find x value at point t. Right. So now let's go and find out what is this t and what is going on with point t. Now, if you look there, you'll notice that point t, in fact, we were even informed in the love letter that point t is a turning point, right? Or a stationary point. Now, at the turning point, aka the stationary point, we know that the graph is neither increasing nor decreasing, which means its rate of change is simply equal to 0, or its gradient is just simply 0. So for you to find the coordinates at the point where the graph is turning, you just need to find the first derivative and then equate it to 0, because at the turning points, the graphs are stationary, which means they're neither increasing nor decreasing. That simply means the gradient of the graph at the turning point is 0. So this is the idea that we use to find the coordinates of the turning point. Okay, cool. So I'm going to go back and find the non-factorized form. Why? Because I need to find the derivative of that. So we were told that f of x is negative 2x cubed minus 3x squared. We also know that this is actually with plus 12x, and we definitely have plus 20, right? So you're going to find the first derivative of this, which is going to amount to negative 6x squared minus 6x plus 12. We're just doing coefficient times exponent, exponent minus 1. Coefficient times exponent, exponent minus 1. This is what you end up with. And the derivative of 20 is a constant. So you should know that the derivative of a constant is always 0. Now, after finding the derivative, we just simply need to equate that to 0. So I'm sitting with minus 6x squared minus 6x plus 12 must be equated to 0. Looks like 6 can go into all those numbers. So I'm just simply going to divide everything by negative 6. If we divide by negative 6, we're going to end up with positive x squared here. We're going to end up with positive 1x here, and you're going to end up with negative 2 here is equal to 0. Now you can factorize this one, right? Let's factorize and see what the answer is going to be. It's going to be x times x, and factors of 2 are just simply 2 and 1. The bigger factor follows the sign of the middle term. This one needs to be a negative so that we will amount with exactly what you're looking for. So according to this, the x values at the turning point, one x value is going to be 1, and the other x value is going to just simply be a negative 2. Now let's go back to the diagram and check if this is making sense. I was kind of expecting this. Why? Because if you look at the defining equation that was given to us for this particular cubic, we've got a repeating factor. That x plus 2 is a repeating factor. And every time when you get a repeating factor, you should know this. You should know that your cubic graph, right? Whenever you've got a repeating factor, your cubic graph does not cut through that x value. It just bounces when it gets to that particular x value, because that x value serves as both a turning point and an x-intercept. So be careful of that. So by just looking at x plus 2 squared, I knew at the back of my mind that that is going to also be a turning point to our graph, right? So now we expected that. That's what is happening. So which means at t, the x value is going to be plus 1. Exactly that's one. Because this one is the one at point A. Therefore, the x value at t is just going to be simply equal to 1. And they only wanted you to find the x value. So if they ever ask you for the entire point, whenever you've got an x value, replace it in the defining equation. It will pop back the corresponding y coordinate all the time. It doesn't matter where you are. When you've got an x and you need the corresponding y value, the graph knows all its points. So just feed it that x value. It will give you back the corresponding y value. Very simple. All right. We're going to the third question now. Third question. Let's see what will happen. Okay, now this one says that we need to find the equation of the tangent. Find the equation of the tangent. Now this is great. Find the equation of the tangent at P, and the coordinates of P were given to us as negative 3 and 11, right? So there's a tangent. You guys need to know, whenever anyone talks about a tangent is a straight line. Now, the equation of a straight line is always given by y is equals to mx plus c, right? Now, what are the ingredients? The ingredients that you need in order to find the equation of a tangent will always be a point and the gradient of that particular tangent. Do we have a point? Yes, we do. Why? Because on this particular graph that goes like this, we were told that at x equals to negative 3, which I'm thinking definitely needs to be somewhere on the left-hand side of the turning point, the far left turning point. There's a tangent. The tangent will obviously touch the graph at one point, much nicer and straighter than what I have there. The point of contact there is negative 3 is to 11. So we already have the point of contact. They told you negative 3 and 11. If they only gave you x, you can replace or substitute this x in the defining equation. You'll get the corresponding y value, which must be 11 according to this particular question. Now, the only thing we are missing here is the gradient. Now, question is, how do you find the gradient of a tangent to a curve at any given x value? Well, you should know that the tangent, the gradient of the tangent will always be the derivative. So that definitely comes from the derivative of this particular cubic function. So let's go back and find the derivative. So we know that the derivative from the defining equation, we did find it right there at the top. We found the derivative to be negative 6x squared minus 6x plus 12, right? Negative 6x squared minus 6x plus 12. So this is the derivative. Now, this is the gradient at any x value, by the way. This is the gradient at any x value. We are interested in finding this gradient when x is negative 3. So we want to find the derivative when x is negative 3, which means everywhere where you see x, you need to replace negative 3. You need to replace that with negative 3 and find out what the answer is going to be. Now let's go and use our calculator. Remember, a calculator is an instrument and not a monument. So you people should use it, particularly a sharp calculator, right? So I'm going to type now. I have got negative, so I'm going to put the negative sign outside, right? Don't confuse minus and negative. Those things are two different things. You put 6 and then you open a bracket. You want to type in the x value, which is negative 3. So you press negative and then you put 3. You close the bracket. There's a square. So you put the square there. Then they say minus. Now I'm going to press minus 6 again, open bracket. There's negative 3. I'm pressing the negative sign next to the equality sign. So negative 3 again, close bracket. So we've got negative 6 into negative 3 squared, minus 6 into negative 3 plus 12. So plus 12. You press the equality sign. What do you end up with? You end up with a value of negative 24. So which means negative 24 is going to be our gradient in this question. So I've got a gradient, my m, you can even call it m, is negative 24. I've got a random point with negative 3 and 11, so I can find the equation of this particular graph. So let's find the equation. Like we said, the equation is always y is mx plus c. My y is 11. My m value is negative 24. The x value is negative 3. We add that with c. You find the product of this, you're going to get, there's a 2 here, 6, 7, I think it's 72, plus c. And then you're going to have to take the 72 or subtract 72 on both sides of the equation. You're going to end up with something interesting. I'm thinking minus 56, but then let's confirm that not minus 56, but minus 61. Negative 61 is going to be our final answer. Okay, so if you do 24 times 3, you're going to end up with 72. If you do 11 minus that 72 on both sides of the equation, backspace, 72, you end up with an answer of negative 61 like we predicted. So negative 61 becomes your C value. Therefore, the equation of the tangent that you are looking for is just simply y equals to negative 24x minus 61. And this will be the solution to this awesome question.